Okay, to draw an equilateral triangle of sides 7 centimeters, we first of all draw a base measuring 7 centimeters, measured with our ruler. We then set our compasses to 7 centimeters apart using that base as our guide. We're then looking for a point which is equidistant from either end. So we place our compass point on one end of the line and draw an arc. Place our compass point on the other end of the line and draw an arc. It's then the case that if we join the intersection of the arcs to the ends of our line, we construct an equilateral triangle of side 7 centimeters. Easy. Okay, to construct a triangle with the sides given of 3 given lengths, in this case 7 centimeters, 8 centimeters and 9 centimeters, we need to pick one of the lengths as our base. In this case, let's say the 9 centimeters. And then we need to find a point that is simultaneously 8 centimeters from one end of the line, 7 centimeters from the other. So we'll need to accurately measure out 8 centimeters there. Now what I'm constructing here is the locus of all the points which are 8 centimeters from this end of the line. Let's, for the sake of argument, call that point A. I now need to find points which are simultaneously the same distance, 7 centimeters, from point B. So I set my compasses at 7, put the point on B, and these are all the points which are 7 centimeters from B. And as you can see, there is one point here which is both 8 centimeters from A and 7 centimeters from B. Let's call it C. And I have my triangle constructed with sides 7 centimeters, 8 centimeters and 9 centimeters. Okay, perpendicular bisector. We're instructed to find the perpendicular bisector of the line AB, where AB is 8 centimeters. So let's carefully draw a line AB of length 8 centimeters. And then want to open my compasses to a distance, and the distance doesn't matter provided it's more than halfway from A to B. Okay, and then I want to place an arc above and an arc below the line. I now want to find the points either side of the line which are the same distance from B. So I leave my compass on the same setting and place arcs above and below the line. Now if you wanted to do a check, you could use a different setting and create another pair of arcs from B, another pair of arcs from A. What you should find is all those points are collinear. They lie in a straight line. And if we were to carefully draw that line through there, we've constructed the perpendicular bisector. This angle is a right angle, and this line has been cut into equal pieces, bisected. Okay, to construct an angle of 60 degrees, we need a baseline. Let's use this one measuring 6 centimeters. Open your compass to that exact distance. Draw an arc. Same setting. Draw another arc. And because those 3 points are now equidistant from each other, forming an equilateral triangle, that guarantees that this angle is 60 degrees. Now to construct an angle of 30 degrees we need to bisect this angle. I'm going to switch colours for this. Okay. To bisect an angle, you start with the point of the compass on the apex of the angle. You then need to put 2 check marks along the arms of the angle. This is to ensure that your angle has arms of equal length. You then effectively create the perpendicular bisector of these 2 intersection points, by which I can do this with one arc, go to the other point that you created, create another arc, and now when you join the apex of the angle through that point, you will have bisected the angle, and this is a constructed angle of 30 degrees. Okay, to construct an angle of 45 degrees, we need to first of all construct an angle of 90 degrees and then bisect it. So if I draw a line, I'm then going to construct the perpendicular bisector of this line, which we've already seen. This creates an angle of 90 degrees. I then, to bisect the angle, put my compass on the apex. We've already seen this with 60 being bisected to give 30. Do an arc and do another arc from those intersection points there, and then if I join the apex of the angle through my intersection of my arcs, this angle here is 45 degrees. Okay, in this one we have a problem to solve. We're told that OA is 16 metres, AP is 18 metres, and OP is 20 metres. Using a scale of 1 centimetre to 2 metres, I'm asked to construct the triangle OAP. Okay, so using our calculation of our 1 centimetre to 2 metre scale, we can see that OA will have to be represented by a line 8 centimetres long, AP will be represented by a line 9 centimetres long, and OP by a line 10 centimetres long. This is similar to the triangle we constructed earlier. I first of all choose one of these as my base. The longest one is often the best because it limits the space you need to move above, but it doesn't really matter. So there is a base 10 centimetres representing 20 metres. I then need to set my compasses to be 9 centimetres apart in order to find AP. I'm going to label this end of my line O, and this end P. So AP is going to be 18 metres or 9 centimetres. So I'm drawing all the points here, the locus of the points, which are 9 centimetres from P. And then want OA to be 8 centimetres long, representing 16 metres, so I set my compasses to be 8 centimetres long. Set the point of the compasses at O and find the intersection point. This will be the point A, which is at the same time 8 centimetres from O and 9 centimetres from P. There's my triangle OAP. Now this is representing 18 metres, and this is representing 16 metres. I'm then asked to find a valuable prize hidden within this triangle. It is equidistant from the apple tree A and the plum tree P, and 12 metres from the oak tree O. By careful construction, we need to find the distance of the prize from the plum tree P. Okay, so first of all, points within the triangle which are 12 metres from O. According to our scale, 12 metres is going to be represented by 6 centimetres on our diagram. So I set my compass to 6. Now here, when I do the arc of a circle, all the points on this circle are equidistant from O. They're all representing points which are 12 metres from O. It's also got to be equidistant from A and P. In order to accomplish this, I need to construct the perpendicular bisector of A and P. So I open my compasses to further than halfway, and then I need an arc above and an arc below. Same from the other end of the line, keeping the compass distance set at the same amount. And now when I join up these 2 points, I'll have bisected AP. All the points on this line are equidistant from A and P. Therefore the point which is equidistant from A and P and which is 12 metres from O will be the point of intersection of these 2 lines here. That's the position of my prize. And with a careful measure I see that this is 5 centimetres from P, representing a distance of 10 metres from the plum tree.